Hello, and welcome to another edition of Dave's Math Slides. Today, we'll be talking about the segment addition postulate. Our objectives today are to calculate the distance between 2 points on a number line and to set up and solve linear equations to find lengths of segments. So let's start about distance. The main thing to remember is that distances can never be negative. If you think about it in real life, a quarterback is never pushed back negative 15 yards. He's pushed back 15 yards. So the distance in geometry is defined as the absolute value of the difference between the points A and B. So we have line AB, and the distance between those two is determined by this formula. AB is equal to the absolute value of x2 minus x1, where x2 and x1 are the coordinates for these 2 points. So we have an example up here where we have a number line from 1 to 8. We have a line that goes from 2 to 7. To find the distance, we take the 2 coordinates and subtract them. So x2 minus x1 could be 7 minus 2, which is 5, and the absolute value just remains 5. All positive numbers inside of an absolute value are positive. However, it can work either way. We could also have the 2 coming first, 2 minus 7, which gets us negative 5. However, absolute value turns negative numbers positive, so in either case, we get 5. So on to the segment addition postulate. Let's say we have a line AC, and in between A, C is a point B. The segments AB and AC all together make up AC. If we were to add those 2 segments, AB and BC, we would get AC. To think of it in an easier context, we think of it as a part plus a part equals the whole. So the smaller 2 segments, when put together, create the whole, the bigger. So let's think of this example. We have xy, which is 23, and yz, which is 50. It says, what is the length of xz? Well, xz is a whole. We have a part. We want to find the whole. So we simply take the 2 numbers, 23 and 50, and add them. 23 plus 50 is 73, so xz is 73. If we were to look backwards, and let's say we were given a line FGH, and they said, find the value of GH. Well, they gave you FH is 36, FG is 21. They want to find GH, this smaller segment. So they gave you the whole and gave you a part. They want to find the other part. So we don't add, because adding them would just mean that the number would get bigger. This number, GH, should be smaller, so we instead subtract. So 36 minus 21 is equal to 15. So sometimes in geometry, they're just going to give you some text, but with no picture, and they'll say something like O is between M and P. Well, if O is between M and P, therefore we would have MOP, or MOP. They also say MO is 22 and OP is 19. Find the length of MP. Well, first things first, draw a picture. Okay, whenever you're confused in geometry, always do that. So we're going to do that. We're going to draw a picture. Okay, look, we have the first comment that we have MP and O is between M and P. Next we have MO is 22 and OP is 19. They ask for MP, which is the whole. 22, or MO, and 19, OP, are the 2 parts. They want to find the whole. Well, if you remember from the first example, when we have 2 parts, we add them together. In this case, MP is 41. Okay, so here's another example. Well, given that A is between T and N, tan, where Tn is 62 and Ta is 18, find the length of An. Again, draw a picture. Okay, so here's my picture. Notice again they gave us Ta and Tn, but A is between. So often a common mistake is that when they read this, they think it goes T, N, and A, or that the N might be in a different place. And they think, hey, we got to add those two together. But no, it says A is between T and N. So no. So Tn is 62, Ta is 18, that's a whole, that's a part. So again, if you remember the other one, we have to subtract. If you don't remember, we have 18, which is a part, plus An, another part, is equal to 62. Okay, so we subtract, which we get 44. Oh, another example. No, wait. Quick check. Quick check. Do we understand it? Were we listening? Were we actually paying attention? Here's two examples to try on your own. Well, as we look at this, we have find LP. Here's the picture, LNP. Ln being 14, NP being 12. It says find LP. Well, LP, that is a whole. So what do we do? To find that out, we have to add the two. So LP must be 26. With QT, okay, we have RQT. RQ is the part, RT is the whole. So when we have a whole and we're missing a part, QT in this case, we subtract. So put the bigger number minus the smaller, which is 10. So we find out that QT must be 8. So here's that example before. So in this case, we have a bunch of linear equations, and we have to find x first. So they give us AR, RT, and AT in the picture. We need to find the length of each segment. So we already have kind of the lengths, but they're in an algebraic expression. So first we have to find x. So if you remember from the picture, we have, if you need a reference, here it is. We have AR and RT. Those are the two parts. AT is the whole. So 4x plus 2 plus 3x equals 8x minus 1. So the two parts equal the whole. Well, first things first, combine like terms. 3x and 4x get us 7x. Plus 2, nothing else added to the constant, equals 8x minus 1, untouched. We now have two linear equations, solving variables on both sides. So one thing we can do is add the constant to both sides. Plus 1. Plus 1, that's where we get the 3. The 7 is unchanged. The 8 is unchanged. So now we move the variables together. 7 minus 7x minus 7x to get 1x. 3 equals x, which is the same as x equals 3. Well, now that is part of our answer, but it's not our final answer. We need to take this x equals 3 and put it in to each equation. So we had 4x plus 2, 3x, 8x minus 1 to remind you. So we plugged it in. 4 times 3 is 12. 12 plus 2 is 14. And then we simply had 3 times 3, which is 9. Now, I didn't need to do this because simply I could just do 14 plus 9 and get 23. But I did it anyways because it's a rather simple problem. We just do 8 times 3, the 3 that we found from earlier, and then subtract 1, which is indeed 23. And we could check. 14 plus 3, is that 23? Yes. So the next is another one of those mysteries where they don't really tell us, they don't give us a picture. It just says that M is between N and O. Find MO and NO. Okay, Mo and No, got to find them. No, in this case we got to do what it said, or we got to do what I told you earlier, which is to, yep, you got it, draw a picture. Okay, so here's the picture. Okay, and also some other information that I didn't disclose, which is, well, first off, M is between N and O. Okay, so N is between, so it's got to be somewhere in between. We don't know how much, but okay. They also they said later, okay, that NM is 17 and MO is 3x minus 5, and then NO is 5x plus 2. So from that information, we're going to be able to find what x is. Notice it doesn't ask for nm. Well, it's because they already gave it to us. They gave us the full value. Okay, here's the small part. Here's another part. Here's the total, the whole. First things first, again, combine like terms. 17 minus 5 is 12. 3x stays the same. The 5x plus 2 stays the same. Again, we're going to subtract the constant to the left side. So subtract 2 to both sides. 12 minus 2 is 10. 3x and 5x remain unchanged, but this time now we're going to subtract 3x to both sides. Now we have 2x. An additional step, divide the 2. 10 divided by 2 is 5. Now our answer is 5. So x equals 5. What we're going to do with that information is plug it back in. So now that we know x equals 5, we already know nm, but mo was 3x minus 5. So 3 times 5 is 15, minus 5 is 10. Now again, we don't necessarily need to plug 5 back in here because we already know nm, so we could have just done 17 plus 10 is 27. But as you can see, if we did plug it in, 5 times 5 is 25, plus 2 is 27. So either way, we would get the same answer. In summary, we should always look, do we have a part? A part? Well, if we have two parts, we add them to get the whole. If we already have the whole in one of the parts, we subtract to get the other part. Thank you very much. That is the end.